my friends, and welcome to my channel. Today's circuit is an off-delay DC timer. Um, it's a timer circuit. When you press the button, it starts a load, but after you release the button, the load still keeps running until a certain time, then it turns off. The most common application for it is the staircase lamp. That's when you press the button to start the lamp, and then it will keep running until you run the whole stairs. The timing principle is simply a slowly charging capacitor. The capacitor is empty at first, but when it is given voltage through a resistor, it will charge slowly. And by the word charge, I mean that the voltage across its terminals increases. This circuit relies on the op-amp. The op-amp is simply a comparator. It's an electronic IC. It has a positive and negative inputs. As long as the positive input has higher voltage than the negative input, it will produce output. So, for the positive terminal, we are using a voltage divider with 10 kilo ohms, so it will actually have half the input voltage here at the positive terminal. And at the negative terminal, we have got the voltage of the capacitor that is slowly charging through this resistor. When the button is pressed, the voltage across the negative terminal, which is the capacitor voltage, becomes zero. So it is lesser than the positive. Then we got output here. But as the time goes, the capacitor charges slowly through the resistor. And just as its voltage is higher above the positive input, which is half the voltage here, the output will turn off. Usually the time constant for a voltage that's charging capacitor through a resistor is calculated as RC. That's the multiplication of the value of the resistor and the capacitor. Here we have 1000 microfarads, that's 1 millifarad against 1 mega ohm. If you multiply these, that should give you about 1000 seconds. 1000 seconds is the time required to charge the capacitor with about 0.63%, 0.63 or 63% of the full voltage. And since we are comparing it to half the voltage, so what actually will happen that it will disconnect a little before 1000 seconds. And in order to use the output used here, we will charge a relay coil. The relay coil will close a normally open contact that will power the load, which is our lamp, through an AC power source. This diode is called the freewheeling diode. Its function is to protect the IC when it disconnects the output to the relay coil. Because if you disconnect the output to any coil, any inductance in general, it will produce a high voltage across its terminals, which might damage the IC. So this diode will circulate it here instead of allowing it to go back and destroy the IC. The IC here, the op-amp, is actually the LM358, and I will show you the schematic diagram of it. It actually contains 2 op-amps on one chip, but we're actually using one and not 2. This is the LM358 pin out. We are using the legs 1, 2 and 3, 1 for output, 2 for the negative input, 3 for the positive input, and of course 8 to supply the power to the IC, that's the VCC, and 4 is the ground or the negative VCC. The second op amp on the right is not used actually in this circuit. Now testing it. As soon as I plugged the DC power supply, it started immediately since the capacitor was empty. It charged quickly, so it turned off. I pressed the button to reset it. Capacitor charged, turned off. Now I'll use the potentiometer to increase the resistance, so increase the timing. If you look closely, you can see the 1000 microfarad capacitor. Yeah, it is that large capacitor on the board. And the IC is between it and the potentiometer. That blue thing is the relay, and that LED is actually the freewheeling die I explained earlier. It's connected across its coil terminals. The 1 mega ohm resistor gives a very long time, and along with the capacitor, the 1000 microfarad, you've got about 15 minutes as max time.